Hi guys, uh, good afternoon to all of you. So today we're going to discuss a topic that is called electrical capacitance. Okay, so electrical capacitance is basically related to its ability to store the electric surge. Now if you consider a conductor and if you give some charge to the conductor, then its potential increases. So that means we can say that if you give some charge, then potential increases. So that means Q is proportional to V. So Q is proportional to voltage or potential. Now here you have to give a equal sign and then a proportionality constant comes to the picture. You can see this is C, and this proportionality constant is called the capacitance. Okay, now the most important thing about the capacitance is that it does not depend on Q and V. Okay, so here you can see this look like that C equal to Q by V, you can write here, but actually C does not depend on Q and V. So we'll discuss all this term in later on. Now this capacitance actually depends on the shape and size of the conductor. It also does not depend upon the nature of the material of the medium. You can use any kind of material of the conductor, so it does not affect the capacitance, but it depends on the nature of the medium. Okay, so that is very important. So if you place a capacitor in a defined medium, then the capacitance may vary from the other medium. So these are the things that depends the capacitance. Now how can you give the definition of a capacitance? Now look at the equation. You can see here, if you put V equal to 1, then C will be equal to Q. Am I right? So the definition can be written as the capacity of a conductor is numerically equal to the surge required to raise its potential by unity. Okay, so when V equal to 1, then C equal to Q. So we can say that is numerically equal to the surge which is required to increase the potential by unity. Okay, now what are the units of the capacitance? So basically the SI unit of capacitance is the farad, and 1 farad can be written as 1 coulomb by 1 volt by the formula that is Q equal to CV, C equal to Q by V. Already we have shown in this equation. So 1 farad can be written as when a charge of 1 coulomb raises its potential by unity, that capacitance is called 1 farad. Okay, then some smaller units we also used. So these are the some smaller units that is called microfarad. So 1 microfarad equal to 10 to the minus 6 farad, 1 nanofarad. So no, 1 nanofarad equal to 10 to the minus 9 farad. Then one more unit is there that is called 1 picofarad, and that can be written as 10 to the minus 12 farad. Now most important thing after units, you always have to calculate the dimension. Okay, now what is the dimension of capacitance? So you see C equal to Q by V, that is coming from the formula. Now V can be written as W by Q, because we know that W is the potential energy and that is related to potential Q into V. So V can be written as W by Q. Now C can be written as Q square by W. Okay, now what is Q? Q equal to IT, you know, this is current into time. So Q can be written as AT, and Q square equal to A square T, or A square T square. Now what is the dimension of work done? F into S. Just put this value and finally we'll get the dimension of capacitance. So by this way you can calculate the dimension of capacitance, which is very important. Now let's discuss the capacity of isolated spherical conductor. Okay, so you can see from the figure this is a sphere, and if you give some charge to the sphere and the charges are uniformly distributed over its surface, these are the charges, and its center is O. Now it's look like that the whole charge is concentrated at its center, and suppose the whole charge is plus Q and its radius is R. Then if the whole charge is concentrated at its center, then what is the potential at any point of this surface? The potential will be same, and what is the expression? That is the Q by 4 pi epsilon R. Okay, so Q is the total charge of the sphere. Now what is the capacitance? Q by V, total charge by V. Just put the value of V here. Okay, so Q get cancelled and this term will remain. So C can be written as 4 pi epsilon R. So from this thing, one thing is clear: in vacuum, C is directly proportional to the radius of the sphere. So that's all about the capacity of an isolated spherical conductor.